Okay, class, today we're going to be learning about key features of the graphs of exponential functions. Yesterday, you were introduced to exponential functions. And what is the difference between an exponential function, which we had here? Remember when you got paid 25 cents just for walking through the door? And then every hour your pay was doubled. In other words, every hour it was times 2 for your pay. And at the end of the problem, you ended up richer than if you had just got paid a straight $10 an hour, because we learned that exponential situations explode very quickly, whereas linear situations are slow and steady. Okay? We also were introduced to the form of the, let's say, the function rule for exponential functions, where A will be our initial starting value and B will be the pattern that we see. In this pattern, it was times 2 the entire time, so that was our pattern 2. And we began with 25 cents. Okay? So, today we're going to learn about key features, typical features of exponential graphs. Just like yesterday's exponential function. Do you remember we had a hard time graphing this because all of these points were so close to the x-axis, there's like no point in even, plotting them. They were all the same. So this flattening of the graph, this flat area, and every exponential situation has a flat area, is called, well, it leads to the asymptote, which is an imaginary boundary line. Go ahead and write that on your paper. This is a very important vocabulary word. It is a key feature of an exponential graph. And for you in Algebra 1 is the only type of function you're going to be working with that has an asymptote. What is an asymptote? Well, imagine you have an electric fence. You've got tons and tons of acres. You've got an electric fence around part of that. And you've got cows. How am I going to grow a cow? Moo. That's a cow. Okay, you've got cows. Now, electric fences are cheap because it's basically just a wire in the ground, okay? Wire in the ground, it's cheap, you don't need all the wood. But every time a cow comes up to it, he says, bzz. All right, so he eventually learns, I can't go past this. I can't go past this. And before you know it, all your cows are nice and corralled in. So that's kind of what an asymptote is. Every time your function starts coming close to it, is like, bzz, it will never, ever, ever get all the way to that asymptote. It will approach it for infinity. And in the case of this first problem here, our asymptote is our x-axis, okay? So our graph approaches the x-axis, or let's say originates from, and it just does this for infinity, forever and ever and ever, but never really gets there. Imagine getting closer and closer to something forever and never ever getting there, all right? Just imagine the cows and the electrical fence. They will never ever get there. They can approach it, okay? So what is the equation of the horizontal asymptote of this graph? You're like, Miss, but it's the x-axis. How am I going to write the equation of the x-axis? Well, the equation of the x-axis is y equals 0. Here's y equals 1. Here's y equals -1. What would this be? Y equals what? 0, okay? So you can put in parentheses x-axis, but I don't want that for your answer. The correct answer is y equals 0. All right? Now, we've talked about an asymptote. Let's look at a couple more asymptotes and we'll move on to domain and range. How about this asymptote? Look at problem 2. Where is this graph flattening? It looks like it will also be the x-axis. And what was the equation for the x-axis? Y equals 0. Okay, let's do one more. Look at problem 3. Where is this graph flattening? It looks like it's flattening at 4. So what is my equation going to be? 4 on the y-axis. Y equals 4. Okay, it's that easy to write the equation of your asymptote. Go ahead and pause the video and try to write the equation of number 4, the asymptote for number 4. Pause the video, compare with your neighbors, If none of that made sense to you, rewind, watch it again. Okay, now let's talk about domain and range. So remember, domain talks about how wide my graph is, and it's discussing my x values, my x, okay? So x-axis is here. So what values of the x-axis are eventually going to be, are eventually going to contain this graph? Like, am I going to be able to draw a box around it? Okay, not really. There are no endpoints on this graph. This goes to negative infinity. This is not straight up, so it is also going to the right. And how long is it going to go to the right? To positive infinity. So how wide will my function eventually be if these arrows go on forever and ever? My function will be infinity wide. So what are we going to say for domain? All what? All real numbers. Now, how about the range? Well, let's do a couple domains first. Okay, so all real numbers, because if these arrows go on forever and ever, what? How wide will my function be? Extra wide. Negative infinity, positive infinity. It will go all the way left, all the way right. Negative and positive. Okay, now use that same logic for number 2. This arrow is not only pointing up, but it's also pointing to the left, toward the negative infinity side. This arrow is pointing right to the positive infinity side. So how wide will my graph eventually be? Infinity wide. All real numbers. Okay, because remember, domain measures how wide my graph will be. Okay, see if you can do problem 3. What is going to be the domain of my function if this continues to go left and this continues to go right? What's the domain of my function? How wide will my graph eventually be? Are you guys getting a pattern here? Good. I should have no problem with domain of an exponential function because you can see they're pretty much all real numbers, okay? The range, however, the range is the part we have to think about because of our imaginary boundary line. Our imaginary boundary line is always going to go bzz as soon as our function comes close to it, so we can't go past that, okay? So it is your job to tell me, where's my boundary line? It's at y equals 0. So, does my graph go down to -1 or -2 or -3 on the y-axis? No, there's nothing down here. There will never be anything down here. My graph stops here. So, my graph is going to be all y values that are what? Greater than 0. All y values that are greater than 0. Do not put greater than or equal to, because remember, it's going to approach this asymptote forever and ever, but it will never get there. It will never get there. So any y value, anything greater than 0, but not equal to. Okay, so do not put a line under that. That's going to be my range. Okay, let's try the range of problem 2. So once again, where's my imaginary boundary line? Thank God we drew that in there. Now we don't have to think all from scratch. That's my asymptote. I should not have put an arrow on that. That's my asymptote right there. So do I have any graphing going on under here? No. So where's my graph? It's anything greater than what? Where's my asymptote? Anything greater than what? Anything greater than 0. Again, miss, is it always going to be anything greater than 0? No. No. Let's do a different example. Okay, where's my asymptote on this problem? 4. Y equals 4 is my asymptote. So is there any graphing going on below the 4? No, it's blank down here. So my range is going to be anything greater than what? 4. Okay? Do we understand how that works? Good, because you're about to do some examples by yourself. Now, let's talk about growth or decay. We all know what growth means. Growth means it's growing, okay? We want to write increasing. Oh my goodness, it says increasing right underneath me. Look at that. Okay, decay means decreasing. So, Miss, what you're saying is you asked us the same question twice? Absolutely. Okay, now, how do we read in English? What does this word say? It says cat. That's how we read. It does not say tack. Nobody's confused, okay? So that's the same way we're going to read our graph. From left to right. Where am I going, up or down? I'm going up. This is a growth graph. It is increasing. Does that make sense? Let's do another one. Number 2. Once again, how do we read this word? From left to right. So, starting on the left, and when I say left, I mean roll your pen to the left, okay? And where am I headed if I trace this graph? It looks like I'm headed down. This would be an example of decay or decreasing. Does that make sense? Excellent. Do we need to do another one? Okay, let's do another one. Here we are, starting on the left again. Trace and see which way you're headed. It looks like I'm headed down. It looks like I'm headed down. This would be another example of decay, decreasing. Your job is to get the rest of this done. There are 7 questions total. Okay, complete all 7 and glue into notebook. You will be responsible for all this work when I see you next. Good luck.